let's go ahead and solve for Rin, which is the input impedance seen this way. Okay, so we're going to do it in a couple stages. Let's look at the model on the left-hand side. So let's say this is our source. Let's say this is the series resistance RS with that. And we have RB, which is really R1 in parallel with R2. Okay. And this is attached to this part, which is beta RE prime. And then let's put the current generator right here. And let's put these resistors right here. So this is RE. And this one here is RL. Okay, so let's call this resistance from here R base. And this resistance from here, we're going to call it Rin or R stage if you want. Okay, so this will be the final result. So whatever we get out of this will be in parallel with RB, and we're done with that. So let's think about what's going on here. We have IB going this way. We have IC going this way. We have a current going through RE, and we have a current going through RL. So let's call this one IE, and this one I0, which is the output. Now, let's think about this for a minute. This branch right here, what's going on? Well, that would be the sum of IC and IB. So in other words, if I had to draw this again, and here's beta RE prime, we know the voltage drop against it will be this IB times beta RE prime. But how about from this point to ground, right? From the emitter to ground. What do we see? Well, we see two resistors that are in parallel, right? With the current going through them, that is IC. Okay, so Vn, let's say from here to here, let's call this one Vn, is really a composite of these two voltages. So let's write it out. So Vn is equal to IB times beta RE prime plus IC times, or let's put an X here just to be clear, RE in parallel with RL. And what is IC anyway? So Vn, again, is going to be equal to IB times beta RE prime, and that's a time again. So let me just be clear on all of this. Just take out the X and just put a dot and do the same thing here. Dot, beta, dot, dot. Okay? Excellent. So dot is our multiply. Good. So what is this? Times beta IB. Okay? So beta IB, okay, that is IC, times RE in parallel with RL. Well, we could factor out the beta IBs here. So Vn is equal to beta times IB times RE prime plus RE in parallel with RL. Okay, but what is R base? Well, if we use Ohm's law, so that would be Vn divided by IB, right? So what is R base seen this way? It's Vn, which is all of this, divided by this current. So what is that? Well, that would be, and then we can get rid of the IB, simply beta RE prime plus RE in parallel with RL. Let's write that down, because our next analysis, we want to find out what is AI. So before I finish anything, this implies now that Rn is equal to Rb in parallel with R base, which is beta Re prime plus Re in parallel with RL. If you want to put parentheses here, that's fine. Okay, and we're going to write that here. So Rn for this circuit is going to be equal to Rb in parallel with beta times little Re prime plus RL in parallel with Re. Okay, let's leave that there. For our next analysis, we're going to look at AI. So that would be our next lesson.